everyone, now we are going to learn about the Karnaugh map. So what is Karnaugh map and why we are learning that? So this is pondering time. So why do you think we are learning the Karnaugh map? If you are already familiar with the digital electronics a little bit, you might know that we require to simplify the things, and to simplify the things, the most important and interesting concept is Karnaugh map. So that's why we are learning the Karnaugh map. Okay, so enough about the Karnaugh map. Just tell me what is Karnaugh map. So for that, we first need to know that what is the kind of simplification I'm talking about. So for that, let's make a table and understand first that what's actually happening and why we are learning the Karnaugh map. So let's take an input x and y. Let's take one more input this time, z and f. F is output, or you can call it output function. Okay, so the thing is like this. This is gonna be our output. This is gonna be our input or inputs. Okay, so now we have 0 0 0. So let's say it is 0, and this time it is 0 0 1, and this is 1. Yes, you have guessed it right. We have just did the OR operation on that. So with just this simple thing, with the 3 inputs, with 2 zeros and z as 0 and 1, we can write the function f is equal to sigma 2. That's it. So this is number 1 and this is number 2. Well, technically we always start writing from 0, so let me change it. So this is 0 and this is 1, so here I also have to change it. So this gonna be 1. So this is the kind of representation I am talking about. This is one kind of the logical simplification that I use the sigma symbol here. Well, this is not it for the Karnaugh map. We have so many things that we need to learn before we learning Karnaugh map, and everything simultaneously get related with the Karnaugh map. So let's learn the basics and learn something awesome. Okay, so let's start with a question that is there any maximum and minimum thing? Well, how suddenly I came to this point? What is maximum and minimum? Well, there is a logic behind. Maximum here and minimum here indicate something. Can you guess that we are going to take and or and or operator? So which is going to be maximum and which is going to be minimum? Can you guess? Well, minimum one is the product, means and maximum one is gonna be or addition. So wherever you see maximum or maxima, so logically we mean here that we are doing the or operation or addition, logical addition in simple words. And wherever we see minimum, we can say it is AND operator, and it is logical multiplication. So why we suddenly jumped into the AND or maximum or minimum? Well, if you are pondering, you are absolutely right. It is related somehow with the Karnaugh map. That's why we are learning, otherwise why we have learned that. Karnaugh map is one of the most easiest way to simplify the things. And to simplify the things, we surely need to learn some basic words first. So I introduced you the basic things. Now, what about the Karnaugh map? Well, Karnaugh map is a presentation of a square shaped things in which we write the inputs just in the form like we can say this is A and this is B. Now let's make some divisions for that. So let's write A can be 0 or 1, B can be 0 or 1. Now when I write the numbers inside these square boxes, like if I write 1 here and 0 here and 1 here and 0 here. So this is the presentation of the Karnaugh map, and this presentation is going to help us understand why the Karnaugh map is used and how powerful it is. So let's first write the equation for that. Equation? Yes, exactly the equation. So let's make a table. Let's make this table again so that I can explain the things in a great detailed way. So is it not detailed yet on? Well, it is detailed, but I want to teach you the ultimate level of the Karnaugh map so that no matter how complex it seems, you can always crack it quite easily. Well, my square is a little messed up. Let me make it as good as possible. Well, it's still not square, but I hope you can understand that it is square. Okay, so A dash here means 0. A means 1, B dash 0, and this is 1. Don't get confused, I'm just making it again so that we can see few things quite more clearly. 1, 1, 0, 0. Now, it's time to write few things. So let's write it down. So A dash B dash is equal to 1. Yes, this is the location. In this location we have 1. Now another one is A B dash is equal to 0. This is the second location, A B dash. Now about the third location, we have A dash B is equal to 1. This is the third location that we worked upon right here. Now it's time for the fourth location, which is A B, which is equal to 0. So why we have written all these things? These all are the functions, and this function is going to represent the Karnaugh map. So this is the information or the inputs at various possible points. Now we need to solve these things and find a particular information. So what is its procedure? Well, the procedure is quite simple. We just need two things at a time. First one, we need to mark where we have ones, because off means by default means 0. So we will skip the zeros. We don't want the zeros here. Just for the ones, if we try to write it again, we need to choose first one and third one from there. So if you look it closely and we add them, so we will get A dash B dash plus A dash B is equal to F. So this is gonna be our function. But it can further be simplified. How? Well, very simple. We can take few things as in common. Like here, we can take A dash common from both the things. So in the first bracket, we are left with B dash, and in the second place, we do have B. Now, if you remember that we have studied that B dash and B becomes 1, so our answer is A dash. Now the answer of the function is finally A dash. So it technically do not depends upon B. It just depends upon A. And this is all the logic behind the Karnaugh map. And the process that we have followed is known as simplification. So we just simplified a circuit using the technique of Karnaugh map. I hope you have understood the Karnaugh map concept using this simple illustration that I have tried. Now we are going to learn the next level of the Karnaugh map. Okay, so why we have learned maxima and minima thing? Well, this is the canonical or standard form where we are going to learn two more concepts relating to the Karnaugh map. The first one is okay, let me tell you everything that we are going to learn about the Karnaugh map. So in the KM we are going to learn the max concept, min concept, and using both of them we will learn something that is called as POS form and SOP form, SOP and POS form. Next thing we are going to learn about don't care condition. Yes, you heard me right. Don't care condition. So we are going to learn the don't care condition that we will care about and SOP and POS form. And why we are learning all these things? If you are pondering, so the answer to this question is the Karnaugh map is used to simplify the circuits. Imagine that you have a very complex circuit. Everything is going here and there and here and there. There are millions of inputs and output. Yes, you heard me right. Millions of input and output. So how a system or machine is going to simplify it at all? It needs something. So of course we are the designers of these things, so we have to come up with something that can make it easy, fast, accessible and understandable, and it should work upon the logic. We cannot go by hit and trial method. So that's why we made Karnaugh map. By using the Karnaugh map we can simplify the circuit and can simply tell that what's actually happening in the circuit. Well, you can call it as the core of the circuit if someone understands it very core. It is more like a hardware hacking. Well, I'm not talking the hacking in a negative way here. I'm talking the hacking like you understand that why and how, what the thing is responsible for that particular function. Like in our case, we learned that finally the function that we have completed by using this simplification is only responsible for a bar or a dash here. Only a dash is determining the entire system. We don't need anything else in this system. So we can just focus on a dash and can leave every of the other thing. And this is the purpose. Make it simple. That's it. Our entire digital electronics is just made to make our work simpler, make the coding done and make the things happen. So that's why we are working and learning all that things. Okay, now let's start with some question. Yes, I am directly going through the questions because Karnaugh map is very simple in its simplest form, but slowly when you proceed the things start changing. Like the thing that we have just learned was two variable. So let's do one more question for the two variable. Okay, so for the two variable concept we have, let's say let's first make a box that we need here. And why I'm calling it two variable? Because it is only having two possibilities, 0 1 and 0 1, and we are just taking two inputs, A and B. Remember, we don't need to write it again and again, but you need to remember that the first one is A dash and the second one is A. Similarly, this is B dash or B bar or B complement, whichever way you like it, and this is B. So we need to remember this thing. Only by that we are able to simplify the things in quite clear, understandable way. Okay, so let's learn something right and wrongs, that what are allowed in the Karnaugh map simplification and what are not allowed in the Karnaugh map simplification. Like there is a 0 and there is a 1. So can we group them together like this and write a simplification? No, this will gonna be a wrong method. So what will going to be the right method? Let's make it quickly again. So this is 0, 1, 0, 1, A and B. So the right way can be if there is 0, 0 and 1, 1 and we group them like this. So this is the correct way of grouping. This is the correct one. Okay, so let's see what else is allowed in the Karnaugh map. My line is a little screwed up. Okay, so let's see the next one. We have covered the first one. Now it's time to learn the second thing. Now imagine that we have again 2 bits. Here 0, 1, 0, 1, A and B. And in the numbers we have 0, 1, 1, 0. And the another one that we have here in a pretty much similar way, but we have a difference here. So we need to figure out that difference. Okay, so here we have in numbers which is 1, 1, 1 and 0. Okay, I added just one more place at 1. So as you already have guessed, this is the wrong concept and this is the right concept. So why it is wrong? In the Karnaugh map system, diagonal are not allowed. Diagonal pairing are not allowed. And why we are pairing all these things? If you are asking this question, I'm started liking you. Well, we are trying to make the biggest pair possible of ones so that we can further simplify it as we have done here. Let's just have a look here as we have done here. And then we simplified it and our answer reached to A dash. So this is the reason we are doing it. Okay, so diagonals are not allowed. But is it allowed? Well, there are 2 possibilities you may see here, like in this one and this one. So which one we are going to take? Well, we are going to take both of them, and this one which you are able to see common in this bracket or in AB, remember AB. So in this one, in this location AB, it will get common out. So we are able to solve it. Okay, now let's proceed to the third one. So in the third one, let's do a question actually, because we have learned few things, right? So the question is pretty much the same. Simplify this. So our question is simplify. So how we are going to simplify this? So let's do it together. So our answer for the simplification is, first of all, you can write all the terms or you can just simply pick up the paired terms. So in the second one, we know that this is right. So we are picking this one, right side one and not the left side one. So first of all, the locations, if you are a little bit confused about the location, so just write it down as A, B and B bars so that you will see them as the coordinates or the positions. Okay, so A, B dash, because this is the first one. So I'm marking it all the time. We are doing it so that you can see every time that what we have done. Okay, now it's B A dash plus, okay, so the second box that we have took is this one, and now it's time to take the third one, the last one, which is B A. That's it. That's all it. Now we are going to try to solve this question. So how we are able to solve this? Well, you can write f as a function. So how we are going to solve it? Well, just simply take the common. Just write a b bar as it is and write b as common. So we have a bar plus a. So remember what is the result of this? 1. Exactly. Well, if you want the clarification, so it is just logical OR and the answer is 1. Okay, so these are the two inputs A and B and we are going to get C. Quick revision, that's it. Okay, now A, B bar. So can we solve it further? Well, not technically. We have just solved it. All the way, it is possible, because we are not able to take anything else as in common. So this is gonna be our final result for now. So we have learned the simplification of 2-bit. Now let's learn the 3-bit. Okay, so what in the 3 bits the different or the difference is? Well, just few more boxes, that's it. Practically that's all the difference it has. Well, I made a box a little huge and you will know in a moment why I'm doing so. Okay, we are done with it. Okay, so we have 3 inputs here. So our inputs are A, B and C. So we're going to write A and B together here and C as separately. So it will gonna be 0 0 0 1 1 0 1 1. We have written every possible combination here. Now C can be 0 and 1. Now to further ease that concept, we just have to write C bar C, and here we can write simply as A B. Here we can write A B bar. Here we can write A bar B, and finally we can write A bar B bar. So this is all the concept that we have here. So this is a presentation and I am leaving you with a question to simplify. Try this question by positioning and simplification, and we will solve this question in the next one. So this is your question and you have to simplify it. So try that for once and we will see its solution in just a moment in the next video. So keep practicing. We will see in the next one. Take care. See ya.